Okay, Algebra 2. This is our second lesson of the year 2020. You are in class and I am not. So we'll be doing this lecture remotely today. Radicals and nth roots. So yesterday we talked about properties of exponents. Okay, so when things are multiplied, you add the exponents. In quotients, you'll subtract the exponents. You see something raised to a power and then raised to a power again, you multiply the exponents, okay? What we're going to do today is talk about radicals and nth roots. So going back and forth between the exponential form and the radical form of expressions, okay? So let's look at a few expressions, okay? So you're very familiar with something like this, square root of 25. So what that means, the square root of 25, what number can be squared to get 25? So the square root of 25, you know that is 5. It means that 25 can be written as 5 squared. That's what it means for the square root of 25 to be 5, means you can square 5 and you get back to 25, okay? Look at the cube root of negative 27. What number can be cubed? Multiplied by itself 3 times so that you get negative 27. That number is negative 3. It means that negative 3 cubed has to equal negative 27. And it does, okay? So let's look at this, the nth root of a, okay? If the nth root of a is b, that means that when you take b and raise it to the nth power, you will get a, okay? That's just what we did in all of these, we're just generalizing. So when you take any root of a number, and you end up with another number, then you can raise that number to the power to get the original expression that you had. So this is what this means to say the nth root of a is b. That means when you raise b to the nth power, you will get a back as your answer. So the way we read this is you see the radical sign there that you see, that the little n, the index, that is read the nth root of a. It means what number can you multiply n times and get an a, okay? So if this is a number, so you can find some number that when you multiply by itself n times, you get a back as your answer. Another way of writing this is we can write the nth root of a is a to the 1 over n. We can use a fractional exponent. So for example, you can write the square root of 25 is the same as 25 to the 1/2 power. You can write the cube root of 27 is 27 to the 1/3 power. Okay, so when you look at this denominator of your exponent, that means the root. So the square root of 25, the cube root of 27. Now we can look at this and see what happens when we take square roots, even roots, odd roots of numbers. So if you've got an even integer, so you're taking the even root, so something like a square root of negative 8. There is no real number that does this. This would have to be complex numbers, okay? So you cannot get a real number from the square root of negative 8. If you've got the square root or any kind of even root of 0, you're going to get one answer that is real, which is 0, okay? If you're taking the even root of a number, like the 4th root of 16, what number can you multiply 4 times and get a 16? That is going to be 2. You'll get one real answer back from that. If you've got an odd integer, so you're taking odd roots. So the odd root of a negative number, you're going to get one number back from that. Cube root of negative 8 is negative 2. 9th root of 0 is going to be 0 because 0 to the 9th is 0. 5th root of 32, what number can I multiply 5 times and get 32? That will be 2. So what you can see here is that if I'm taking even roots, square roots, 4th roots, 6th roots, I run into a little bit of problem when I try to take the even root of a negative number. I'm going to get complex numbers. So we're really not going to do a whole lot with complex numbers this semester. We did more of that with the quadratics, but we'll allow you to say at this point, square root of negative 8 is not real, okay, or square root of negative 25 is not real. So we're mainly working over this set of real numbers with our exponential properties. So let's evaluate some of these. You really have to concentrate on what's going on here. So the cube root of negative 64. So I'm taking the odd root of a negative number, that's allowed. So it tells me what number can I multiply 3 times. So is there a number you can multiply 3 times and get negative 64. Well, that number is negative 4 because negative 4 times negative 4 times negative 4 equal negative 64. Okay, the square root of negative 64. Square root of negative 64, this is not a real number, okay? If you were to do this, it would be 8i would be your answer, okay? But there is not a real number for the square root of negative 64. The square root of 1 over 64, okay? So this is the, you can write this is the square root of 1 over the square root of 64, which is just 1 over 8. Okay, it should mean that when you square 1/8, you should get back to 1/64th, and you do. Negative of the cube root of 64. So what is the cube root of 64? What number can be multiplied 3 times and give you 64? That is 4. So this answer is just negative 4. Negative of the square root of negative 64. Okay, the square root of negative 64 is not real. Okay. So this is not a real number.